If we want to find this integral with the function z times e to the negative 1/2 z squared, and so let u be 1/2 z squared. The derivative of u with respect to z, it'd be 1/2 times 2z, which is z. So we have du is equal to z dz. And so the integral of z times e to the negative 1/2 z squared will be e to the negative u, since u is 1/2 z squared, and then z dz is du. The antiderivative of e to the negative u will be negative e to the negative u. U is negative 1/2 z squared. We can rewrite this as negative 1 over e to the 1/2 z squared. So this is a negative exponent. When we move it to the bottom, it becomes positive. And therefore the original integral, the lower limit of integration is negative infinity. The upper limit of integration is positive infinity. And so we can rewrite this as the integral from negative infinity to 0 plus the integral from 0 to infinity. This improper integral, we can write it as the integral from b to 0 with the limit as b approaches negative infinity. And then this improper integral, we can write it as the integral from 0 to c, where c approaches infinity. The antiderivative of z e to the negative 1/2 z squared is negative 1 over e to the 1/2 z squared, and then the same thing over here. And then evaluating from b to 0, when z is 0, we get 0 here. E to the 0 is 1. Negative 1 divided by 1 is negative 1. And then when z is b, then in the place of z, we have b. And then same thing over here. When z is c, we get negative 1 over 1/2, negative 1 over e to the 1/2 c squared. And then when z is 0, we get 1/2 times 0, which is 0. And e to the 0 is 1. Negative 1 divided by 1 is negative 1. And this is the lower limit of integration, and so it would be minus negative 1. As b approaches negative infinity, 1/2 b squared approaches positive infinity. E to the positive infinity is infinity. Negative 1 divided by infinity is 0. And so we have negative 1 minus 0. C approaches infinity, then 1e to the 1/2 c squared approaches infinity. Negative 1 divided by infinity is 0. So we have 0 minus negative 1, which is 0 plus 1. So we end up with negative 1 plus 1 is 0. And therefore this integral here is equal to 0. This is the graph for the function z equal to y equal to z times e to the negative 1/2 z squared. This is what the graph. And so looking at the graph, we can see that the area from 0 to positive infinity is above the x-axis, and then the area from negative infinity to 0 is below the x-axis. So this is a positive area, this is a negative area, and we can see that they're the same. And that's why we end up with 0. So this area plus this area is equal to 0.